Okay, so today we will continue should be chapter 6. Chapter 5 should be chapter 6, numerical integration, because yesterday is chapter 5, numerical differentiation. So I will cover only Simpson's 1/3 rules and Simpson 3/8 rules. Okay, so let's go to the intro of this chapter. So numerical integrations, we have few methods, few techniques. Start with the trapezoidal rules, Simpson 1/3 rules, Simpson's 3/8 rules, and Gauss quadrature. Gauss quadrature have 2 points and 3 points. So actually in your syllabus, the topic that's covered is only this one. These three only, but I will explain the trapezoidal rules because it's the basic. Before we go to the Simpsons rule, I think that's better for you to understand how the numerical integrations is doing. So the trapezoidal rules is the easiest way. So I will explain this one first, okay? Even though that is not covered in your syllabus, but I also will explain it. Okay, so why we need to do numerical integration? So similar to the previous chapter, similar to the numerical differentiations, where there is why we need to use this one? Why we need to use this one? First, when there is when we only have data, when only data is provided, when only data is provided. Okay, that means there's no functions, no equations, no function is given. Okay, for example, let's say we have a data like this, x and y. Okay, this is the value of x, and then value of y. When x is 0, y is 3. When x is 1, the value of y is 5. When x is 2, the value of y is 8. Let's say this one. And normally when we want to do the integration, we have to have an upper limit and lower limits, a and b. So now, so based on this one is from 0 until 2. So basically we have to have like this, right? So this one is start from 0 until 2, but y, we don't have the function of y. So we cannot solve it using the analytical, the integration that you learned before. So that's why we need to do numerical methods, because this function is not given. Okay, so this is the first reason why we need to use numerical integrations. And the second one, when the functions is too complicated, or it cannot complicated or do not have the exact solutions. Or do not have an exact solutions. Okay, for example, like let's say this integrations from 0 until 3, and we have to integrate, or we don't have the exact solution, so we have to do numerical integrations. So in the last chapter, you learn about the differentiation. So differentiation is actually, if let's say we have a graph, like when we have a graph, we have a, let's say we have a point like this, okay? And then we want to find the tangent line, okay? We want to find, let's say this is the fx. So we want to find this, the slope or the gradient of the function. So we do differentiations. So for the integrations, when we do integrations for functions, a graph, let's say, so when we have a 2 point, let's say here, okay, so let's say here, this is a A and this is a B. When we do integrations, that means we want to find the area under this curve. Okay, so that means we want to find the area under the graph. Okay, so this is when this, let's say this is a fx, so we integrate from the A, upper limit is B, and then fx dx. So we get this one, the area. So not only area, we also can do the volume, find the volume for sure. When you have an area and when you just get the, so before this you learn about 3D, 3 times integration, second integration. So after we get the area, and then we can calculate the volume, okay, on the any problems lah. Okay, we start with the first row that I mentioned just now, trapezoidal rows. Okay, let's consider we have a graph like this. Let's consider we have a graph like this. So when we have a graph like this, okay, so basically how we are going to find the area under this function, this graph. Let's say this is a fx graph lah. Okay, melalui, okay, these 2 points. Okay, so you look at kalau lah saya buatkan jadikan, let's say I make it like a trapezium. Okay, it's a trapezium like this, right? Trapezium, we want to find the area of under trapezium. Normally here is the A, here is the B, and this is a height h. So when we define this area, 1/2 A plus B times h, right? So saya title dulu, terlupa title. This is trapezoidal rows. Okay, let's say, and then I can actually just draw like this. Draw, okay. Take like this. I draw like this, the line like this. Okay, so that means I can get this one in the trapezium. Can find the area of this trapezium, right? So this one, where that here, this is the, let's say I assume at this point, this is a x0, and this is a x1. At B, that is a x1. So this, at this point, so at this point, this is fx1. This, at this point, this is fx0. So when I do integrate, okay, I will get this area, the whole area. But this one, nampak, sini saya tak dapat. But actually, I want this area. But here, I don't want, but it's estimate over here. So here, this is actually this, here is the error. Because numerical methods, we only find the solution, we just approximate, do the approximation, okay? So in order to reduce this error, nampak error ni besar kan? We can divide this trapezium into several segments. So saya akan pecahkan dia kepada beberapa segmen. Kalau yang ni kan, sekarang ni, when I want to find this area, let's say this area A, so I will get area is equal to fx0, okay, plus with fx1 time with h. Kalau h near here, this one. So here is actually is b minus a, this h. So here this value is actually like this lah. Time with b minus a. So jadinya b minus a over 2 fx0 plus with fx1. Okay, ini untuk dapatkan area. So sekarang saya nak reduce this. I want to reduce this error. This error. This is too much. So I will divide it into several segments. Sekejap saya copy this one, this graph. Let's copy this graph. Okay. So sekarang, okay, when I want to make it more, the error is more smaller, ataupun, so I will divide it into several segments. Let's say I divide into 4 segments. Let's say I divide into 4 segments. Let's say 1, 2, 1, 2, 3, 4. Katakanlah sama lah. Walaupun yang ini tak sama Let's say this one, the H, the step size is same. Sama lah. Katakanlah ini semua sama. Okay. So I divide it into segments so that I want to find A1, A2, A3, A4. So, and then I will rename all the point here. Okay, so here I put it is as a X0, and this is a X1, this is a X2, this X3, and this is a X4. Okay, saya namakan balik, and here for sure the value here will be Fx0, and this is Fx1, this is a Fx2, Fx3, and this is Fx4. Okay, so sekarang now I want to find if let's say I draw this one become the trapezium one by one. So that means when I want to calculate it, okay, so I will connect these 2 points. This one is the first one, and then this is the second one, trapezium. This is the third trapezium, and then this is the fourth trapezium. If you look at the trapezium now, you see the error yang kat sini becomes smaller compared to just now, right? Now this is the error. This is actually the error. Compared to just now, you see the error is so big. So when we divide into several segments, the error will be smaller. Now, let's combine. Let's find the total area. So sekarang saya kena ambil the value of A1. Okay. So A1 will be half time width. Okay, since jarak dia daripada sini ke from X1 minus X0, right? Jarak dia. That is the distance H of H. So I have to time with F X0 plus with X1. And then A2, okay, this is the A1. This is a A1, okay. And then A2, 1 over 2, H is X2 minus X1, Fx1 plus with Fx2. Ini kan, kalau awak tengok ini kan, this one. Look back, let's say this one. Kan, awak tengok compare dengan yang this. Okay, so this is A, right? And this is B. So A adalah Fx0 and B is Fx1. So where A plus B here? A plus B. Sorry. This one, A plus B. And then half time width, this is the H. Okay, H is X1 minus X0. Okay, so I continue with the second area. Let's say this one. So this one, okay, if X2 minus X1 times with Fx1 plus with Fx1 plus with Fx2. So now A3 is half x3 minus x2 f x2 plus with x3. Okay, so this is the area, third area here. And the fourth area, A4 x4 minus x3 fx3 plus with fx4. Okay, so this is the yang ni keempat, this one. Okay, so when I want to combine all of this one, so for sure the total area will be A1 plus A2 plus A3 plus A4, kan? So kalau if let's say you look at this one, perhatikan sini, we will have like semua half, okay? All is half, okay? Here, this is half. And then time with this is all a H, okay? Tak kisah lah, because all the H, the step size is same. So sama lah, okay? So now we go to F0. Kalau tengok, here we have one F0. And we will have only one F4. That means the first value of Y not lah kiranya, Y0 and Yn, okay? Because now we have only until 4. Ini daripada kosong saya. So the first and the last, kita akan ada sekali je appear. And when you look at, let's say you look at this one, Fx1. X1 ada 2 kali. Nampak? And then if you look at Fx2, Fx2 is appear twice as well. And then you look at Fx3 is appear twice as well. Dia akan appear 2 kali. Cuma yang first dengan last saja yang dia appear sekali saja. Yang tengah-tengah semua tu, segment tu, all this value, this one, this one, this one, dia akan appear 2 kali. Cuma yang first value and the last value akan appear once. So it's come out dia punya trapezoidal punya formula jadi macam ni. Start from the A until B, dia punya lower limit is A, upper limit is B. For the function x, dx is equal to h over 2 times with f0 plus with fn plus with 2 summation of fi. So boleh nampak, yang ni yang pertama punya. Okay, this is the first value and this is the last value, and yang tengah-tengah semua tu kena darab 2 sebab dia akan appear 2 kali. Okay? Okay, so this is the trapezoidal roles. Okay, now so far ada masalah? Do you have any questions so far? If no, we continue with the Simpson 1/3 roles. So far okay or not? Okay. Okay, we continue with Simpson. Saya copy satu lagi ke sini. Put here. Okay. Okay, now continue with Simpson. Simpson's 1/3 rule. So for this Simpson 1/3 rules, for this method, we will have to divide the interval start from A to B into n. What is n? Is the even segment. Okay, macam ni. Ataupun saya boleh cakap that is a subsegment lah. Contoh just now, we have A, B, C. Yang ni kan, saya lukis balik. 4 area just now. I draw back these 4 four area. We want, ini kan kita pecah tadi. We divide into 4 segments just now. Okay. And then one more thing is in the, ini tadi yang kita, we want to find A1, A2, A3, A4. Okay. For the Simpson's wanted rows, yang dia kata sekarang ni, we want to divide this one into n equal to 2. Maksudnya kita jadikan dia an even. Contoh dalam ni saya pecah lagi. Saya pecah lagi kepada 2, 2, 2, oops, 2. Dia kena pecah, dia bukan pecah kepada 2 saja, dia boleh pecah kepada even, tak kisah. And can be 2, 4, 6, 8, and so on. That is a multiplication of 2. We have to multiply. Or 2. Have to multiply with 2. If you like, kalau tengok sini saya ada berapa subsegment n? Saya akan ada 1, 2, 3, 4, 5, 6, 7, 8. Now my n is 8 already. Yang tadi pun sama, boleh juga. Tadi pun sama. Kebetulan tadi saya pecahkan kepada 4. So that's it, here n is 4. Okay. Kalau let's say I just want, let's say I only have 1 to 5, this one 3. Tak boleh. Kalau macam ni saya kena pecahkan lagi supaya dia jadi an even. Boleh faham tak? If let's say just now I only divide into 3 big segments, so I cannot solve it using Simpson wanted row. Because Simpson wanted row, I have to make sure that the subsegment is even number. Okay, so sekarang saya pecah kepada sini macam ni, and now when we want to find the h, the value of h is equal to b minus a divide with the number of n. Sekarang h, sini and h. This is h. So you look at here, we have a and b. Okay, daripada a sampai b, from a to b, we have to divide with the how many n. So now the n is 8. So if let's say this one, the h will be b minus a over 8. Okay. So the n have to be even number. Okay. For the Simpson's wanted row. Sekejap A bit warm. Okay. So now, if let's say now I want to find the area of all this one. So sekarang saya jadikan, okay. Now I want to find, okay, dia punya formula untuk Simpson's row is like this. A is equal to summation integrate from lower limit upper limit fx dx, dia akan sama dengan h over 3 sebab, okay, f0 plus 4, this is f0, 4 f1 plus f2. Okay, so macam ni. Okay, kalau lah saya kira let's say I calculate A1 is, okay, so A1 is from here. Let's say this is x0 and this is x1 and this is x2, x3, x4, x5, x6, x7, x8. Okay, so here with as x0, fx1, fx2, fx3, fx4, yang ni fx5, fx6, fx7, fx8. Okay, so like this. Okay, so A1 will be h over 3 times with f0, and this is A1. Okay, so f0 will be this one, fx0, okay, plus with 4fx1. Yang tengah ni. So at the middle, dia akan kena kali 4. This one, the middle one. So plus with fx2. Okay. So A2 will be h over 2 fx daripada fx. Sini tengok. Daripada sini. Here. FA2 plus with yang tengah dia adalah FA4 times with FX3 plus with FX4. Okay. And then X3 will be H over 2. This one. Okay. So start from FX4 plus 4 FX5 plus with fx6. Okay, and then A4 will be h over 3. H over 3 fx5, 6. Sini, start from 6. Yang 7 tu tengah. Okay, 6 plus with 4 f7 plus with fx8. Okay, so the summation of A will be equal to A1 plus A2 plus A3 plus A4. Okay, kalau tengok ke sini, okay, all of having the same H over 3, right? Cuma kat sini, kalau tengok in more details, okay, the first fx0 is appear once, okay, and then sama juga dengan the last fx8 is appear once. Cuma kalau orang tengok yang f1 is 4 times f1, and then this one f3 4 times s3, s5 x5 4 times x5, and then this 7. This is the odd. The odd number yang ganjil tu, kalau tengok, semua tu dia akan darab dengan 4. And yang number yang genap, okay, genap, ambil color kuning, okay. So here, F2 is appear twice, 2 kali. X4, 2 kali juga. X6, 2 kali juga. FX6. So, dia jadinya, dia punya formula untuk Simpson's wanted row sebenarnya jadi F, A, B, Fx dx is equal to H over 3 F0 plus Fn. Yang pertama, the first, this one, this value and this plus this value, okay, plus with 4 times summation of fi for the odd number plus with 2 times the summation of fi even number. Macam tadi saya terang tadi. So this is the equation of Simpson 1/3 rows. So kalaulah the n is not even number, we cannot solve using Simpson 1/3 rows. So we have to ensure that the n, ini yang kita pecah ni, segmen ni mestilah an even number. So we only can use this Simpson 1/3 row. Okay, so try look at the example. Okay, we try an example. So far okay or not? Class, okay or not? Semua okay? Are you still with me? Ada yang terkeluar? Okay. Okay, thank you, Ken. Okay, now we go to the example. Okay, let's see. Example 6.3 in the book's numerical method, page 132. Okay, so it's asked we to approximate these functions 1 over 1 plus epsilon x, power of x. For the upper limit, for the lower limit, negative 2, upper limit dia, kosong ni lower limit. And this is upper limit. Okay, that means from negative 2 to 0, okay, for this function by using by Simpson's one-third rule with n equal to 8. Okay, so n equal to 8, this is a even. Okay, ini genap. So we can use Simpson one-third rule. Kalau tak boleh. Okay, so start with the first step. Step 1, okay? Step 1, we have to find h, the step size first, okay? So h is b minus a divided by n. Okay, now n is given. If let's say they give you h, for example, 0.25, let's say. So then you have to find n, okay? So make sure that the n is even number. You only can solve using Simpson one-third rules, okay? So now the n is given, so we have to find the h. So a, daripada sini, lower limit, this is a. And this upper limit, this is a b. So a is negative 2 and b is 0. So put in here, b is 0 minus dengan negative 2 divided by n is 8. So that means 2 divided by 8. So we get 0.25. So h is 0.25. Okay, so now after we already know the step size, so that's mean like this, okay? So start from here, the graph, let's say here, we start from here, start from a negative 2. So the step size will be 0.25, okay? So the next value will be negative 1.75. Okay, and then dia akan step size lagi 0.25. The next value of x akan jadi negative 1.5 and then seterusnya. Okay, so you no need to calculate this one, you just can use calculator, but cuma okay, you have to make sure either you have this calculator or this calculator. Yang jenis satu lagi, yang the older one, you cannot use this one to help you to do the table. That means kalau siapa yang guna for those who are using Casio FX57MS, okay, so you may not be able to do the table that I will explain later on. So that means you have to do manually. The table you have to draw in manually. Maksudnya awak kena calculate sendirilah dia punya setiap jarak ni. Okay, so on. So now I want to teach you, you no need to calculate, so it will come, you can use your calculator. So I use this one calculator first, okay? So here, when you have, if let's say you have this one, you have to press in the menu, okay? So we want to get the 8 ke 9, wait it's a 9 table, okay? Go and find this table. Okay, if kalau tahu pergi functions, pergi press number 9. Okay, so dia akan keluar, it will come out like this. It will ask you about your function actually. So basically, you just key in this value, That means 1 over 1 plus epsilon power of x. So I will key in 1 over 1 plus shift ni, yang ni alpha x, okay? So I will press equal. So we ask you gx. So we don't have the gx. We don't have another function. We only have one function. So here you just press 0. Okay, equal to. So it will ask you the table range is from where. So start will be the lower limit. Start from negative 2. Lower limit is 2 over a. Negative 2 equal to. So n at 0. So upper limit is 0. So I press 0. So how about the step size? So tadi kan kita calculate the step size is 0.25. So I will key 0.25. So this is step size. So the table range is from negative 2. Okay, here from negative 2 until 0 with the step size 0.25. Okay, press OK. Sama dengan. So dia akan keluar. Keluar terus macam ni. Table. This is the answer, but you have to put in the table in yourself. Sebab yang ni kita pening tengok macam ni. Okay, I bring this table. Okay, so the next step is we have to build this table, basically. Okay, so ini step 2 lah. Okay, what is inside this table is we need I, okay, xi. So here the fxi. Okay, so sini I will put f0 and fn. Okay, the first value and the last value, okay, because it's only appear once. So here I will put f odd number, and here I will put f even number. Okay, okay, this one because later on I want to summation all of this one. Okay, so sekarang daripada sini table, you look at here, we will have 1, 2, 3, 4, 5, 6, 7, 8 kan? Okay, okay, sampai 9, okay, sampai kosong. So sekarang masuk je. Here, start from -2. Okay, ikut dia. Okay, daripada -2, -2, -1.75, make it smaller. Like this. Okay. Lepas tu, kita tengok -1.5, -1.25, -1.0, okay, -1.75, kurang satu. Mine is one more. Tak habis. This one more row. I don't think that I can add. I cannot add because this is a picture. Sorry. So this one, 0. So no need 0. Don't need negative. Why? So this is 0. Okay. So and then now I want to key in the value of, alamak, saya silap lah. Wrong. I'm wrong. Sorry. This one should be value of x. Aduh, this one is x. This one. Dah sudah blur. Okay. This one is 0. So this one is start from 0, 1, 2, 3, 4, 5, 6, 7. Total we have 8. Okay. So this one. So the value of fx0 yang ni. So kalau lah ikut, if let's say you key in the value of, if let's say in these functions, okay, these functions, 1 divided by 1 plus exponent x, if let's say we put the x value of x is -2, so we get this one 0.880779. So that means 0.8808. So I take 4 decimal places. Okay, so saya akan tuliskan sini. This is the, because this is the first one, F0, 0.8808. Okay, and then continue. Okay, so this is the, now we are in the 1. So 1 is odd. So I will have to put in this column. Okay, so now this one is 0.8520. Okay, and now the next one is x3. So x3 is actually the x2. 2 is even number, so I will put here. Okay, saya akan tulis di sini. So now okay, now this one is 0.8176. Semua boleh faham tak? Are you okay? Now, the next one is will be a odd number again. So, awak jangan tengok table ni in here, right? Because the table, it will start from 1. But actually, we will have to start with 0. X0 kan biasanya kita start dengan X0, X1, X2 sampai Xn. So here the table will be start from 1. So try to remember that you have to follow your table, your own table. So this one is X0 and the last one is X8. For this one, ini last kali. So yang last kali pun saya akan letak di sini. So now odd number I will put in this column, F0, F odd. Even number I will put in a F even. Okay, so next is 1.25, negative 1.25 if this one. Okay, so this is 0.7773. Okay, and then here I will key in the next one is 0.7311. Okay, and next is ini adalah back kepada this one is sorry. This one is even number again. This one also even number. Okay, so ini adalah 0.6792. Next, 0.6225. Next, 0.56222. And then the last one, 0.5. So 0.5 saya letak di sini. So boleh faham tak? So this one, in order it will be more easier later on, we want to do a summation. Kita kan kena ada darab. Ada yang odd number, we have to multiply by 4. Even number, we have to multiply by 2. So now, after you get this one, I think I have to draw back the table. Sorry. To draw the table. Continue table saya dah habis. It's like this, like this. Okay. Okay. And then I want to find the summation value. This is the summation value. That's total value. So dapat kan total value kat sini. So for example, this one. So go back to 1. Okay. So 0.8808 plus with 0.5. So we get 1.3808. Okay. And then this one 0.852 plus with 0.7773 plus 0.6792 plus 0.5622. So you get 2.8707. 2.8707. And then the next one is summation of this all even number. 0.8176 plus 0.7311 plus 6225. So you get summation. The total amount of the F even is 2.1712. Okay. So apabila dah dapat macam ni, oh sorry, I forget to explain to those who are using this calculator. So it's the same for those one who are using this calculator, tapi I'm very sorry, the appearance is very small like this, okay? So you have to press the mode here and you have to choose table, number 7, okay? Choose table and then you key in similar to just now. So key in the function just now, 1 over 1 plus shift ln alpha x. So you press equal to, so we ask you gx equal to 0 and start from -2 and 0 with the step size 0.25. So we'll get the same one. So only that means you just, okay. Boleh Cuma dua calculator ni saja. Kalau tak, yang kalau guna Casio FX570MS, then you have to write on. You just have to calculate. It won't help you to do the tables, okay? You are not able to do this table. Okay, so now, saya besarkan this. So now, go back to the formula just now. Remember this one, tak ada kat sini. Sorry. Dia punya formula for the Simpson's wanted rule. So the step 3. So we have to put in the formula let's say here -2 until 0, 1 plus x dx will equal to h over 3. You can see f0 plus fn plus with 4 summation of fi odd plus with 2 times with summation of fi even. Okay, so that means h is 0.25 divided by 3. f0 plus yang ni kan kita dah kira these two, where this one is this one. So this one is 1.3808 plus with 4 times with yang ni tadi kita kira summation in this one is this one. Okay, so 4 times with 2.8707 plus with 2 pi with this one just now we calculate for the even this one yang ni. So this is 2.1712. So dapat, so we get 1.4338. So this is the area for these functions using Simpson wanted rows when n is 8. Okay? So far okay or not? If okay, then we move to Simpson 3/8 rows. It's the same thing. Only apa yang Simpsons. Okay, so I go back to just now, Simpson wanted row here. Okay, just now, Simpson wanted rows, we divide the segments, the sub-segments, right, into n equal to multiplication of 2, multiple of 2. Okay, so that's mean even number. So for the Simpsons, okay, here, we put right here. Simpson 3/8 rows. Simpsons 3/8 rows. Untuk Simpson 3/8 row, if you divide the segment, divide the saya panggil sub-segment lah, okay? I call it sub-segments into multiplication of 3, multiple of 3. Okay, that means n can be 3, 6, 9, 12, 15, 18, and so on. Okay, dia cuma mesti n is multiple of 3, multiplication of 3. Else we cannot use Simpson 3/8 rows. So this kenapa dia maksudnya for the Simpson 3/8 rows, okay, let's say we have, kata sekarang we want to saya pecah kepada 3 lah katalah. Okay, this one. Let's say I want to find, okay, 1 itu pecahkan kepada semacam ni. Dalam ni, okay, inside here I will divide into 3 segment. Coba 3 lagi. Tadi pecah kepada 2 saja. Even number saja. Now is 3. Okay. Semua tu akan pecah kepada 3. Let's say here, this is x0, this is x1, x2, x3, x4, x5, x6, x7, x8, x9. So ini dia punya value lah, fx0 lah kan. Okay, so here this is fx9. So here fx6, here fx3. Okay, so if here this one, okay, when you want to find the h, same equation, b minus a divided by the n, where the n have to be in the multiplication of 3. Okay, so kalau lah ikut, okay, let's say for the Simpsons 3/8 row, the formula will be 3 over 8h times with f0 plus with 3f1 plus with 3f2 plus with f3. Macam ni. Okay. So daripada sini, let's say I want to find A1. A1 is equal to 3 over 8 times H. So H saya adalah X3 minus X0 lah. Okay. So this one is F0. F0 is Fx0 plus 3 times Fx1 plus 3 times Fx2 plus Fx3. Okay. Sini. Okay, so this is Fx1, Fx2. Yang tengah-tengah tu lah. Okay, yang tengah tu kita darabkan 3. Okay, and now go to find the value of A2. So A2 is equal to 3 over H Fx3 plus with 3 Fx4 plus with 3 Fx5 plus with Fx6. And then A3 equal to 3 over 8H Fx6 plus with 3 Fx7 plus with 3 Fx8 plus with Fx9. Okay, kalau, so this one is the A3. Okay, kalau tengok here, if you look at here, okay, F0, the first one, this one will appear once. F9, the last one, also will appear once. Kalau kita tengok this one, yang F1, F2, appear 3 kali, times 3. F3, this one, 4, 5, 7, 8. We have to multiply by 3. And when you look at this one, X3, Fx3 ada 2 kali. And then Fx6 ada 2 kali. Where this one is those yang multiply by 3 punya. Multiply by 3 punya. Dia akan apply 2 kali. So, yang selain daripada, that mean no triple. Yang bukan triple punya, we have to multiply by 3. Yang triple punya, we multiply with 2. Dia akan appear twice. Okay, if you apply twice. So here, come up the formula. So A will be A1 plus A2 plus A3 lah. Okay, so here come the formula of Simpson 3/8 rows. Fx dx into 3 over 8h times with F0 plus with Fn plus with 3 summation of F3i minus 2 plus with F3i minus 1. Okay, and then plus with 2 summation of F3i. Kalau tengok, this one is actually, this one is triple value. Yang darab 3 punya. Triple number. And this one is non-triple value number. Okay, yang bukan. So, if we try, let's try go back to the same example just now, but now we use Simpson 3/8 row. Just now we use Simpson 1/3 row, right? Now we try to use Simpson 3/8 row. Okay, so go back to, example 6.6, they are same. Now, approximate, okay, this function by Simpson 3/8 row with n equal to 9. Okay, so n equal to 9, this is multiple of 3. Okay, multiplication of 3. So, okay, then we can use this Simpson 3/8 rows. Okay, 9, so can. Okay, so step 1. So step 1, we have to find h. H is b minus a divided by n. So b is 0 minus, again, negative 2, and is 9. So now the step size is page 134. So the step size is 2 over 9. Okay, so kalau buat pecahan, terus pecahan lah, doesn't matter. Okay, so and then step 2, we have to do it using the table. Inilah table. So let's draw the tables. Step 2. So the table.
Doktor,
Yes.
saya nak salin soalan je.
Salin soalan. So here we have to put, okay, this is I, this is XI. So untuk F, XI, saya akan pecahkan kepada one is F naught and one is Fn. Macam tadi. Not and Fn. Cuma here, I will put this one is yang bukan triple and this is triple number. That means multiple of 3. Okay. So, oh sorry. So kalau lah, alamak. Salin soalan. Dah habis salin soalan. Soalan yang sama. Cuma now Simpson 38 row. So sini, alamak. Sorry. Here, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ada satu lagi tau. Okay. Now, kita nak daripada negative 2. So, last kali 0. So, tak kisahlah sini macam mana awak. So, I will use calculator again. So, calculator, choose mode and then 9. This one. So, you have to key in the formula. This one. 1 over 1 plus shift ln ini alpha x. So sama dengan gx is 0. So start from negative 2 until 0 with the step size is 2 over 9. 2 over 9. So step size dia macam ni lah. Okay. So ini dapat tak? Saya jadikan dia pecahan lah, senang. Okay, so here is negative 16 over 9, negative 14 over 9, negative 12 over 9, negative 10 over 9, negative 8 over 9, negative 6 over 9, negative 4 over 9, lepas tu negative 2 over 9. And then saya akan, now I will key in the first F x naught. F naught do, so this is the value of x naught. So I will put here 0.8808. Okay, so if this one, 1 is it multiple of 3? No. So I will put in here, this column. And 2, is it multiple of 3? No. So I also will put in this column. Okay. So when there is a 3 here, so I will put in this column. Okay. So 6 also I will put in this column. And 9 is the last one. So I won't put in here, but I will put in Fn. Okay. So now just copy, put in the table. So,
Doktor.
Yes.
Sorry, I nak tanya. Yang calculator tu kan, satu dia negatif 2. So kita buat naik atas
Satu negatif 2. Tak faham saya.
Tu kat calculator doktor kan? Satu,
Yeah.
lepas tu yang X tu negatif 2. Tapi dekat yang doktor tunjuk ni negatif 16.9.
Mana? Yang ni ke? Yang ni?
Negatif 2 kalau kat sini.
Okay. In calculator, dia tak ada start dengan kosong tau. So, you kena make sure you have to write your own table here. So, sebab kita kena start dengan X naught. N kita. Sebab yang dalam table dia memang start from 1. It will start from 1. That's why it's a bit different.
Okay, Doktor.
Yes, okay.
Thank you.
Okay, welcome. So now I will just key in the rest. Okay, so here make sure this is a 1. So when there is a negative 16 over 9, your value is 0.88. 8554. So we're key in this column. 0.8. Sorry, 8554. So the next one 0.8257, and then the next one, okay, yang seterusnya adalah F3. So F3 is multiple of 3. So I will put in this column, a green column here. 0.7914. Okay. And then the next one, saya akan terus ke sini pula. 7523. And then 7523, 0.7087. And then this one is 6, number 6. And number 6, this is multiplication of 3. So I put here. Okay. And then 0.6093. And then last kali, satu lagi, 0.5553, and then last kali 0.5. So 0.5 I will put here because this is Fn, the last one. After that, I have to calculate the total summation. Inilah kiranya saya dapatkan dia punya summation of this value. Okay, so now I will calculate. Sama je lah yang macam tadi kan, yang ni. So this is a 1.3808. So go back here, press 1. So 0.8554 plus with 0.8257 plus with 0.7523 plus 0.7087 plus with 0.6093 plus with 0.5553. So we get 4.3067. 4.3067. And these two value, fx3 and fx6, okay? 0.7914 plus with 0.6608. So we get 1.4522. Okay. So apabila dah dapat ini, so the next step 3, we use the formula of Simpson's 3/8 rules. Di mana, okay, negative 2, 0, 1 over 1 plus epsilon x dx is equal to, dia kan 3 over 8 times h, right? F plus f plus with 3 times with fi, macam ni, 3i minus 1 plus with fi 3i minus 2 plus with 2 summation of f 3i. Okay. Kalau tak nak tulis ni pun tak apa, awak tulis summation of multiple of 3. Bukan multiple of 3, and this one is the triple number. Oh, boleh lah. This one is, sorry. No. So yang ni bukan triple, and this is triple. Okay. So that means here 3 over 8 times 2 over 9. H step size 2 over 9, right? So here, this one is 1.3808. Yang ni yang kita dah kira. This one is actually this one. Okay. Plus with 3 times with yang bukan multiple of 3. This one. Yang bukan multiple of 3. So this one. So you put here. So this one is 4.3067. Okay, plus with yang multiple of 3. Yang multiple of 3 yang ni adalah this value. So plus with 2 times with 1.5, 2, 2, 2. So you get, calculate je lah. So you get same, 1.4338. Boleh tak? So cuma satu tu, we divide into, one is odd number and another one is even. But this one, for the Simpson 38, we divide into non-triples and triples value. So far okay or not? So dah habis sebenarnya. That's all on actually Simpson 1/3 and Simpson 38. Trapezoidal rows is not covered in your syllabus. I only explained only just now. So, okay. Class macam mana? Okay lah so far? Boleh digest tak?